Dear students, today we will discuss transportation problem using northwest corner method. So actually, northwest corner method is used to calculate initial basic feasible solution for a transportation problem. And transportation problems are specially used to calculate minimum transportation cost from sources to destination. But in some cases, you might be asked that what will be the maximum transportation cost required to fulfill demand from the available sources. So to how to calculate the maximum transportation cost, that we will going to discuss in today's presentation using northwest corner method. So we see the procedure to calculate to solve initial basic feasible solution using northwest corner method. So what is first step? First step, you have to check whether the problem is balanced or not. If the problem is not balanced, then you have to convert that problem into balanced problem by either adding dummy, demand or supply. If the demand and supply are same, then we can say the problem is balanced problem. If demand and supply are not equal, then you have to add either demand or supply, which is minimum one. Then you have to, the problem will become balanced problem. Then you have to convert maximization problem into minimization, and for that what is procedure? To convert maximization transportation problem into minimization transportation problem by subtracting each transportation cost from maximum transportation cost. From the transportation cost matrix, you have to identify which is the maximum transportation cost, and from that cost, all other remaining cost you have to subtract. If you do that, you will get new matrix. That matrix is called as minimization matrix. So we have converted maximization problem into minimization. Once you identify the problem into minimization, then you have to solve the LPP, this transportation problem using northwest corner method. The second step is that select the upper left, that is northwest cell of the transportation matrix, and allocate maximum possible demand or supply values. You have to identify top left corner cell, that is northwest corner, and you have to check the available demand and available supply, which is minimum. That value you have to allocate for that northwest corner cell. Once you do allocation, then you have to check whether demand and supply, which value is maximum. If supply is maximum, then you have to move horizontally. If demand is maximum, you have to move vertically. And if demand and supply both are zero, then you have to move diagonally. This we have studied in step number 3. So in this fashion, you have to navigate from top left corner to bottom right corner. So in northwest corner method, starting say allocation cell must be the top left corner, and last ending cell must be bottom right corner, and all demand and supply values must be zero. This you have to check while solving northwest corner method for transportation problems to calculate initial basic feasible solution. We will see one simple example, then you will get easily understood the procedure to solve transportation problem using NWCM, that is northwest corner method. What is the example? Solve the transportation problem to find maximum initial basic feasible solution using northwest corner method. Here the word maximum indicates that the problem is for maximization, and the costs are given. S1, S2, S3, these are nothing but sources, or you can just source which is having capacity to supply 7 units, 9 units and 18 units respectively. Likewise, D1, D2, D3, D4, these are nothing but distributors which are having demand of 5, 8, 7 and 14 units. So this 19 is nothing but if you want to supply a single unit from source S1 to demand D1, then 90 rupees will be the transportation cost. So taking into consideration all these costs, you have to distribute available 7 units among these 4 distributors in such a way that there should be minimum transportation cost. There should be minimum transportation cost. There should be minimum transportation cost, and the demand get fulfilled. the transportation cost will be minimum, demand will be fulfilled, and supply will be zero. So for that purpose, what you have to do? The first you have to check whether the given problem is balanced or not. So you have to do addition of all supply, addition of all demand, and you have to compare. So here supply is equal to 34, demand is equal to 34. So the problem is balance problem. Then second thing what you have to do, you have to check which is the maximum cost matrix. So these matrices are called as cost matrix. So from these, which is maximum value? 70. The 70 values are two different places. So maximum value is 70. So what you have to do? Sorry. We are discussing about northwest corner method. So in the northwest corner method, what you have to take into consideration? You have to select northwest corner of this transportation matrix. So here, this is my northwest corner. So before that, to convert the problem into maximization to minimization, what you have to do? You have to check maximum cost, and from that cost, all other costs you have to subtract. When you do this, then you will get converted maximization problem into minimization problem. Then you can solve using NWCM. So when you subtract the values, what you will get? 70 minus 19, 51. 70 minus 30, 40. So here we will get the converted cost matrix, which is in minimization form. Getting? So here total demand equal 34 units, total supply equal 34 units. Hence given problem is balance transportation problem. The first thing we have verified. Second, we are going to convert maximization into minimization. For that, what is the procedure? To convert maximization problem into minimization problem, you have to subtract each transportation cost from maximum transportation cost. The maximum transportation cost was 70. So by subtracting all costs from 70, we get this new revised matrix or new revised transportation matrix. Now how to solve this? We have to start allocation from top left corner. From this corner, we have to start our allocation. So if I select this cell, then what is demand and supply? Demand is 5 units, supply is 7 units. So out of these, which is minimum? 5 is minimum. So I have to allocate 5 units here. So I have to subtract 5 from demand and supply. So 5 minus 5 is 0, 7 minus 5 is 2. Then this demand is 0, so I have to ignore this first column. Then we have to check demand and supply value with this allotted cell. The demand is more, so supply is more as compared to demand. So we have to move horizontally. So in next iteration time, we should be in this cell. Okay, in this cell. What is the value? For this, the demand is, supply is 2 units and demand is 8 units. Supply is 2 units, demand is 8 units. So which is minimum? 2 is minimum. So we have to allocate 2 here. We have to allocate 2 here. So when you allocate 2 here, then you have to subtract this 2 from supply as well as demand. So 2 minus 2 is 0, 2 minus 8, 6. So this value becomes 0. So I have to ignore this row. When you ignore this row, we have to identify which is my maximum supply or demand. Demand is maximum. So in next iteration, we have to move vertically. We have to move vertically. So you will reach in this cell. So in this cell, when we reach, we have to compare the supply and demand. The supply value is 6, demand value is 9. So minimum value is 6. So we have to allocate 6 here and subtract 6 from demand and supply. We get 0 demand and 3 supply. So 0 demand indicates that supply value is more. So we have to move horizontally. If supply is more, we have to move horizontally. If demand is more, we have to move vertically. So in this case, supply is more. So for next iteration, we have to move horizontally in this cell. So when you are in this cell, you have to check demand and supply. Here demand is 7, supply is 3. So in this case, minimum value is 3. So we have to allocate 3 here. So when you are allocating 3 units, then you have to subtract the 3 units from available supply. So 3 minus 3 is 0. 7 minus 3, 4. So when you subtract the 3, when you subtract the value from supply and demand, you have to check which is maximum. Here demand is maximum. So for next iteration, we have to move vertically. So we will reach in this cell. So when we are in this cell, we have to check the demand and supply. So here demand is 4 units, supply is 18 units. So minimum is 4. So we have to allocate 4 units for this cell and subtract 4 from demand and supply. So demand becomes 0 and supply becomes 14. So when we compare demand and supply, we come to know that supply is more. So we have to move horizontally. When you reach at this cell, we have to check demand and supply. So demand is 14, supply is equal to 14. So you can allocate 40 units here and subtract this 40 units from demand and supply. You get 0 demand and 0 supply. So in northwest corner method, the allotment starts from top left corner and ends at bottom right corner. And you have to check the demand values and supply values. If all values are 0, then we can say the example is properly solved. Now how to calculate total transportation cost? Here we have to check whether degeneracy is obtained or not. How to check that? We have to calculate how many demands are there. There are 4 distributors, there are 3 suppliers, 3 plus 4 7, and rule is m plus n minus 1. M is 4, n is equal to 3, minus 1 is 1. So 3 plus 4 minus 1 is 6. And how many allocations we have made? 1, 2, 3, 4, 5, 6. So m plus n minus 1 is equal to number of allocations. Hence, degeneracy is achieved for initial basic feasible solution. We have achieved the degeneracy. Now to calculate total cost, we have to take into consideration the original cost. These are the 51, 40, 20, 60. These are the converted cost from maximization to minimization. So you have to take the original maximum cost. So after putting those values, we will get 90, 30, 50, 10. These are the original cost. So to calculate the total cost, we have to multiply 5 into 19 plus 2 into 30 plus 6 into 30 plus 3 into 40 plus 4 into 70 plus 14 into 20. And if you solve this expression, you will get rupees 1015 is the maximum cost required to transport or to supply these number of units to these different distributors in such a way that the total supply will be 0 and the supply total items remains will be 0 and total demand will be 0. So means everything is fulfilled. All demands will be fulfilled, all supply will be fulfilled. In this fashion, you can calculate, you can solve the transportation problem for maximization using northwest corner method. So if you have any doubts regarding this, you can call me on my mobile number. My mobile number is 98500 My name is Dr.B.J.Mohite. So we will stop here. If you have any doubts, you can call me. Thank you.